What is the acceleration and how do you get there? Anyone? Yeah.
I figured since it was in the middle point, there would be no acceleration because it's just reaching the point when we stop accelerating, so it's just slow down after 0 point.
Okay. An idea with reason. That's great. Anyone else? No? Those who did it? The bottom? Whoa, let's start at the top.
Well, it was still moving in a circle, so they had to have acceleration toward the center. And at that point, I knew that it wasn't speeding up or slowing down in the tangential direction, so that was a total acceleration.
And how for some reason was shaking his head?
No, it's not. So the acceleration needs to be perpendicular.
But at that point, it's not changing at all.
Okay, now,
It's speed. It's still changing.
so if I can characterize some of your reasoning, you recognized it as being something.
I recognize the whole thing as circular motion.
Okay, so recognition, previous knowledge, go ahead. Do not start from scratch. Now, okay, anyway, let's have a look at Jack. I'm going to give the conclusions about thinking up top, although they only emerged. So, episode 1. For some reason, Jack's linear motion schema was activated, and we figured out later with Jack why this was. Once you isolated this section, he forgot about the circular part. He said, oh, look, speed's going to be the same there and there, by symmetry. And he said, well, wait a minute, it's not actually symmetric, right? It's going on in one way, but I don't think it will matter. And he said, if the speed's the same there and there, and the acceleration is 0, so that's fine. So he said, acceleration is 0. Very sensible reasoning if you're in a linear motion schema, except, then he said, well, wait a minute, it's actually changing speed all the time too. But I don't think that will matter. It's kind of adjusting his thinking a bit. So he said so, expert thinking, but focused on whatever got activated. That's our interpretation. So what happened next? He said, oh no, what have I done? He looked again and saw, well, an activation of something else in your beautiful circular motion. So, he instantly drew the solution. He didn't work it out. He just drew the acceleration pointing upwards, just like that. He was just drawn it because he knew that was the case. If this was uniform circular motion, that was the solution. There wasn't anything else. You did not have to work it out. Quick, instant, as long as you're in the right frame of thinking. Once he'd done that, he didn't stop, but he activated his force schema. He said, oh, well, that's because it's a net force upwards. And then, which confirmed his ideas, but then he said, wait, it's not that simple actually, because there's force down, the weight, there's a force up, that's the tension, and so it must be one's bigger than the other to give the net force up. So he was pursuing, this was a sideshow from the question, but it all bore on confirming his thinking. So that was very interesting. He brought in forces, and then there was a very unexpected thing that occurred. He suddenly realized it was non-uniform motion. And he knew that from teaching. So he just took a detour into forces. Into that case, he recalled an entire picture from a textbook. This was the picture. Those of you who taught it may recognize it. The forces at the top and bottom of a complete circle, where the weight's acting. At the top where the weight's acting with, and at the bottom where the weights acting against the string tension. That was interesting because it shows that cognition just doesn't stick to things, it jumps all around, sort of relevant, but not quite. And then something even more interesting happened. So that's a deviation off task, but he was happy because it was not think aloud, he didn't have to be on task. He even remembered that there was an interesting result about how the tensions in the string hit the top and bottom. Now, I don't know if you can see it, what Jack might have thought from this, but basically, he decided he knew by how much the string tensions differed, top and bottom. He asked him, I don't know, and he said, well, you just look at the sketch, and at the bottom there, the weight is opposing, at the top it's helping. And so the difference in string tensions to get the same centrifugal acceleration would be twice the weight. And so the string tension is going to differ by twice the weight. And he said, I was really pleased with that. He wasn't so pleased a little later, but he was really pleased with that kind of thinking. Do you think he's right, and do you know why he wasn't? Sorry?
The treatment of
right, he wasn't quite right, but his thinking was very interesting, and he clearly had the insight to see what he was doing. He just hadn't noticed that for that it wasn't anything to be. And that's how his thinking went. He did return to the problem. He was happily off task there. So his outcome, that was his solution. Acceleration upwards, very confident. He got it by case knowledge. Wrong first time. Principles, didn't really use them, but they were below the surface. Force, he introduced that, and he was willing to adjust cases to fit. And he was clearly very good, but his reasoning wasn't as expected. Now, there were other points on the pendulum path, and the interesting thing is that for each of them, his reasoning was incredibly complex, with different approaches for each point. He ran into trouble with the force approach. We were quite surprised. So was Jack. I'll tell you what I'll do. I'll just show you what he did for the end point. Very quickly, I won't do it properly. For the end point of the pendulum, which is like this. He didn't work from principles at all. He just said, well, this is like the ball at the top of the path. I know all the results for the ball at the top of the path, and therefore I know the answer is that it's not zero. And he drew in a common misconception that he wouldn't fall into the trap that this was stopped there, that the acceleration was zero. This is all compound knowledge. Then he activated a car analogy, and he said basically, this is like a car starting out, and I know the acceleration's in that direction, so fine, it'll be along the way it's starting out. And then he said, oh, I'll have to do an adjustment. It's curving at the same time. So my first thought was to go this way, but I know it's curving a bit. You know what he tried to do? He tried to say, well, look, if it's starting out and curving, then instead of the acceleration being in that direction, maybe I should just adjust it a little bit to take into account that it's speeding up and curving. Now this was an expert thinking, but you'll notice how he hadn't had a case like that before, and he was using very, very common everyday practical heuristics, kind of compromise a little bit of each type of reasoning. Okay. So that